Hello everyone. This last lecture is on operating a vehicle, and the operating costs involved in a vehicle are categorized into two categories. Either these costs are fixed costs or they are variable costs. Now, variable costs are just like the fuel cost or the gas cost because not every month you drive the same number of kilometers, obviously. So one month you pay more for gas, one month you pay less for gas. So that means that the gas cost per month is not etched in stone fixed. So that's a variable cost. Another example is oil change. You do the oil change almost every 3 months, every 4 months. You just do an oil change. It's not like every single month you take your car for an oil change. So that is another variable cost in operating a vehicle. Tire rotation, you do it maybe like every 10,000 kilometers. You don't do it like every month. So that's a variable cost. 1 month you do it, 10 months you don't do it. License plate sticker, again, that's like happening only once a year, not like every month. Bridge tolls, well, you're traveling to the United States or you have to pay road tolls. That's not happening every single month. So that is a variable cost. It is categorized into that category. But there are other costs of operating a vehicle, and that's fixed cost. And one of them is car insurance payments. Your car insurance payment is like every month the same amount you pay. Or the lease payment, for example, your monthly lease payment is like $350 every single month, and that doesn't change from March to April, from April to May. Every month is the same. A monthly parking permit. Some people have monthly parking permit because they want to park their car in designated locations. And every month they pay, for example, $50 to save that spot for themselves. So these are examples of fixed costs involved in operating a vehicle. The others were variable costs that are changing from month to month. Speaking of insurance, when you sign your contract for the car insurance, they give you two options. They say either you can pay your car insurance premium on a monthly basis. Every month you pay, let's say, $342. Or if you want, you can just make one lump sum payment of $3,800, which would be an annual payment. So the question is, which one is better? If you pay $3,800 for one whole year, that's one-time payment you make for the whole year, and then you don't pay anything else. But if you make monthly payments of $342, let's see how much you end up paying in 1 year. So $342, all right, times 12. I'm multiplying it by 12 because there's 12 months in every year. So 342, the answer is $4,104. Okay, so you see that when you make your insurance payments in the form of monthly payments, you end up paying more at the end of the year compared to the case where you are making your car insurance payment annually only once in the form of a lump sum payment. So 4,104, that's 3,800. The difference is like $304 right there. So you are paying $304 more for 1 year because of having this convenience of making your car insurance payments on a monthly basis. Okay, if you don't want that, then you have to pay $3,800, a big amount, with a one big lump sum payment that you make at the beginning of the year. So we see that the differences between monthly and annually payments for car insurance, and which one is more convenient. Probably monthly is convenient. And which one you pay more. Well, in the case of monthly, you end up paying more when you calculate for 12 months. So that's speaking of insurance, car insurance. And the other thing you want to talk about is depreciation. We talked about brand new cars and used cars, okay? When you buy a brand new car, everything is new. It doesn't break down. It has warranty. Everything is like perfect. But after you continue using the vehicle, you drive the vehicle for like um, so many kilometers, the vehicle starts depreciating in value. And depreciation is the amount that the value of a vehicle decreases over time. So a car that is worth $30,000, after 10 years, it is not worth $30,000. It is much, much more cheaper because it does depreciate. And this is not true only for vehicles, this is true for almost many things in life: computers, electronics, DVD players, TVs, computers, laptops, cars, motorbikes. There are many, many things in life that they depreciate in value over the time when you use them a lot. Okay. Um, and on the other hand, there are other things in life that they appreciate in value, such as house, property, land, jewelry, gold. You know, so cars fall under the category of depreciation. So the new car price, whatever it is, when you subtract the value after a certain time passing by, that difference is the amount of depreciation. Okay, so let's say the car is worth $35,000. After 1 year, it is worth $30,000. So 35,000 minus 30,000, that is 5,000. So that means that the amount of depreciation for that vehicle was $5,000 for the first year. Some cars they depreciate more in the first year, and some cars um, have like a different depreciation rate compared to the other cars. There's something called percent depreciation, and that is the actual amount of depreciation, that so-called 5,000 I was talking about. That actual depreciation divided by the new car price times 100%, that is called percent depreciation. There's an example here. New car price is $32,500. We assume the rate of depreciation is 23% per year. We assume it's constant. And we want to calculate the price after 2 years. And also want to find the percent depreciation after 2 years. Want to do these two calculations. So the price is 32,500, and it depreciates in value 23%. So the price is actually 77% of the original price after 1 year. Why? Because 23% is gone. That's called depreciation. So 1 minus 0.23, that would be the price of the car after 1 year. So I just call this like um, V sub 1, which means value of the car after 1 year. So 32,500 times 1 minus 0.23, that's 25,025. 25,025. So this is the price of the car after 1 year. If you want to know how much it depreciated, what is the actual depreciation, you just do subtraction. You subtract this from $32,500. That will be the amount of depreciation or decrease in the price of the car. Now, we want to find the price after 2 years. So it depreciates in value after 1 year at a rate of 23% per year. And then for the second year, again, the same rate applies. So it will be 32,500 times 1.23 to the exponent of 2. Or I could have grabbed 25,025 and times it by another 1 minus 0.23. It doesn't matter. And this time, we're going to find the answer. So it's 32,500 times 1 minus 0.23. The exponent is 2. So we get 19269. 19269. Hopefully this is what you got on your calculator. And 0.25. So this is price after 2 years. So this is the price of the car after 2 years. Okay. What was it originally? $32,500. What is the actual depreciation? Well, we do a simple subtraction. So you do a subtraction. So actual depreciation would be 32,500 minus 1926 9.25. Divide this by the, no, we just want to find the depreciation. I thought we were calculating the percent depreciation. So let me do the subtraction. Minus 32,500. It is, yeah, so $13,230.75. So this is basically the actual depreciation. So a simple subtraction does it. That's the depreciation. How much the price has decreased actually after 2 years. This much the price has gone down. All right. Now we want to calculate the percent depreciation after 2 years. So this actual depreciation we just found, we're going to divide it by the new car price. So perhaps I can do it here. So we have 13,230.75 divided by the new car price, which was 32,500. So this would be the percent depreciation, PD. And of course, this would be a decimal number, which if you multiply by 100% in the formula, it will become a percent. So this actual depreciation divided by 32,500, it gives me 0.4071. So this is 0.4071, which is actually 40.71%. Okay, so percent depreciation for this vehicle after 2 years, it's 40.71%. It means that it depreciated by this percentage. So I hope you understood the formula percent depreciation and how we do the calculations. Maybe you can watch this again and redo it by yourself. And then by doing a couple of practice questions, you will get hang of it. It's not very difficult or complicated. You just find the actual depreciation and divide it by the new car price and times it by 100%. That will be the percent depreciation. So I got 0.4071. If you multiply it by 100%, you can express it as a percent instead of a decimal. The next thing we want to talk about is something called fuel efficiency. Fuel efficiency is a measure of how far a car travels per unit of fuel. Usually it's indicated by the unit of liters per 100 kilometers. Let's say if we say such and such car, let's say Toyota or whatever, has a fuel efficiency rating of, let's say, 9.2 liters per 100 kilometers. It means that when you drive that car for 100 kilometers, the amount of fuel that the engine consumes is about 9.2 liters. That's the meaning of it. Fuel rating here is 13.8 liters per 100 kilometers for a given car. The capacity of the gas tank is 60 liters. The gas price out there is 102.9 cents a liter. We want to find out how far one can travel with this car on one gas tank, which is 60 liters. So we're going to say, in order to travel 100 kilometers, okay, the engine consumes 13.8 liters of gas, as per the fuel efficiency rating given in the problem. But now we have 60 liters in the gas tank. That's the capacity. So in order to travel 60 liters, in order to consume all the gas in the tank, which is 60 liters, how many kilometers, I put X here, can the car travel? So I'm constructing a proportion basically. Distance over distance, liters over liters. So when you construct a proportion, the best thing to solve any proportion is by cross multiplication. So 60 times 100 equals 13.8 times X. So when you divide both sides by 13.8, you get the answer. So 6,000 divided by 13.8 gives me 434.78. So 434.78. Unit of measurement is kilometers because X was a distance. Okay, so this means that if you use 60 liters of gas with a fuel rating of 13.8 liters per 100 kilometers, you will be able to travel a distance of 434.78 kilometers. Okay, that's the meaning of it. All right. And the next question is, what is the cost for traveling 74 kilometers one way and back? let's say you want to go to the city of Mississauga to meet with your relatives, okay? And then you want to return back to your own city. And the distance one way is 74 kilometers. So if you want to go there, meet with your cousin or relative or whoever, and then come back home, that means 74 kilometers you go and 74 kilometers you come back. So the total distance traveled would be 74 times 2, which is 148 kilometers. So in order to go and enjoy a party or meeting with your cousin, you have to travel 148 kilometers. Okay, and what is the cost for traveling this distance? That's the question here. So the cost we know is 102.9 cents for 1 liter. Okay, for 1 liter, that's the price. Now we want to see how much money we should pay if we want to travel 148 kilometers. Okay, so first of all, we have to see for 148 kilometers, how much gas are we going to consume? That's the first thing we have to find out. Okay, and then if we know how many liters of gas should be consumed, we're going to multiply by the unit price, and then we're going to find the cost. Very easy. So I'm going to say 100 kilometers. The rating is 13.8 liters like before, but now we want to travel 148 kilometers clearly, right? So we want to go to Mississauga and come back, so 148 kilometers. And what is the amount of gas we need? How much gas will the engine consume? So from here, 100x equals 13.8 times 148. And by doing a quick calculation here, 13.8 times 148 divided by 100, it gives you 20.42. 20.424. So this much liters will be consumed by the engine. Now, for every liter of gas, you pay 102 cents, right? So for this much gas, you have to pay the cost would be the amount of liter times 102.9 cents a liter. So the answer would be in cents. So if I multiply this by 102.9, that will be 2101.6 cents, which would be $21.02 actually, right? So the cost would be $21.02 if you want to travel 74 kilometers. And now this is another scenario with $25. How far is the distance that you can travel? So we're going to construct another proportion here. We're going to say $25. We can say with actually $21.02. Okay, we could travel a distance of 148 kilometers, right? But now with $25, okay, how many kilometers should we be able to travel? So kilometers over kilometer, dollar over dollar. It's all about constructing a proper proportion and then solving the proportion by cross multiplication. That's all it is. So here we can find x equals 25 times 148 divided by 2102, and the answer will be 25. I do the math. I hope you have the calculator with you. So I got 176. So 176 kilometers. Okay, so with $25, okay, you can travel 176 kilometers, and with $21.02, you can travel 148 kilometers. So it's all about constructing these proportions properly and doing the cross multiplication and solving for the unknown in each case. Okay, I hope you understood the fuel efficiency calculations, depreciation, car insurance, and the two types of costs that we have in operating a vehicle, fixed costs and variable costs. I'm sure you'll be reading the textbook as well, and you will practice and learn how to do these calculations. Okay, thank you very much and good luck.